Hello everyone, welcome back. So in today's session, we will be starting up with the module 2 and the drainage side. That is nothing but the plumbing part, module 2, drainage side. So let's quickly move on with the module 2 of the plumbing drainage. So chapter 1, let's begin up with. So chapter number 1 is introduction to the drainage. So first of all, we'll be seeing what exactly is drainage. So what is drainage? Drainage, the definition of it is all the used water leaving your property through a well-laid network of pipes. As we all know that we do have n number of fixtures or n number of appliances in the project, and that demands water at the same time that needs to be drained out the water from that specific fixture. Okay, so that is being done by means of the pipes. Okay, so that is what the drainage, the water which is being draining out from that fixtures by means of pipes and all this, you can say as a drainage. Now there is a difference between drainage and a drainage system. System is something which is combination of, like you can say, the piping and fittings, accessories, and directly connected to the public sewer or the manholes and all this. So let's see this, what exactly is the drainage system. The arrangement provided in a house or a building for collecting and transporting wastewater and a sewage through drain pipe by gravity to join either to a public sewer or a domestic septic tank is termed house drainage or a building drainage. So as you can see here, it has been clearly saying that we do have a set of pipes, and that pipes is carrying the water and transporting the water. It might be any kind of water, it might be sewage or it might be wastewater. It is transferring through the drain pipes, and that drain is happening by means of gravity. Okay, and that water by means of gravity, it is being sent either to a public sewer or a domestic septic tank. Now public sewer, you know that is nothing but a municipal pipe, you can say, or authorities pipe, where we will be connecting our drain lines to that pipe, or we can dump into that. Or else if there is no public sewer, then the authority will recommend you to have a domestic system or a domestic septic tank for dumping all the sewage of your project in that specific septic tank. Okay, so now this system is called as the house drainage or a building drainage system. Okay, so this is a building drainage system or a drainage system. Okay, so the main aim for this building drainage is to maintain a healthy atmosphere within a building. Okay, because like we might see that you might sense some kind of bad smell or a foul smell or odor in the internal of building. That is not accepted. Okay, so just to maintain a healthy atmosphere. Why? Because not only the odor and all this, the smell or the sewage gases or the sewer, when it is being dumped or it is being drained out, when the gases try to repel back, if it is entering into the room or in a building, it not only comes with the smell and all this, it also consists of some bacteria that is hazardous, or that would be some problem for humans. Okay, so just to maintain a healthy atmosphere, it is to be the drainage system to be provided. And like example, if someone has used any of the fixture, it is been the main one of the aim of the building drainage system is to drain off the water or the sewage or the wastewater as soon as possible from the building. The same thing is given. We can maintain a healthy atmosphere within a building in the means of to dispose of the wastewater and sewage as quick as possible to avoid the entry of foul gases from the sewer or septic tank. There might be repel of the gases from a sewer or a septic tank. We will not allow that. Okay, so that is also one aim of the building drainage system, and to collect and remove the waste matter in a systematical manner. Okay, so this is how the main aims of a building drainage. Now, if you pay attention to this, you can see this image. This is a house in which we are having is like, this is a toilet area and this is bathroom area. For example, if you see here, here is one WC, here is a laboratory, and here is one kind of bathtub maybe. Okay, so when the drain is happening, this is by means of a pipe is being connected below this floor. Okay, and it is collecting the drain from the WC, likewise from the laboratory, and likewise from the bathtub. Okay, so when there is a flush or when there is a drain coming out from this fixtures, this will be carrying along in this, and this is being transported to this public sewer. Okay, you can see here. So this has been dumped into this. Okay, so this is what I can say is nothing but drainage system. Okay, so this is the thing what we need to deal up with. Okay, so we'll be seeing this. This, what you are seeing is called as, I can say, as a building drain, which is collecting all the water in a single pipe, and it is being dumping into this public main, and this is nothing but a manhole over here. So this is how it's gonna be. Okay, so I think you got an idea for the chapter number 1 that what exactly we are dealing. So we did some introduction to the drainage and what do you mean by drainage, and we have seen like what are the main aims of the drainage in a building. So we have seen this. There are two types of drains generated generally. First is sewage and second is excreta. What do you mean by sewage? The wastewater, that means the water which is being collecting or which is being draining from all the fixtures of the entire building except WC, urinal and within. That comes under sewage category. So the same thing, if you see wastewater which is generated from the kitchen sinks, showers, bathtubs or bath, you can say, or you can say floor drains or washing machines, is nothing but this all water is called as sewage. Second is what? Excreta. This is one more drain. Excreta is nothing but the drain which is being collected from the toilet seats, below the toilet seats, or you can say from the WCs, urinals and bidet. That is nothing but excreta. In simple words, the drain which is coming out from a WC, urinal and a bidet which contains human waste is called as excreta. Remember this. Okay. So these are two types of drains which is generated in general. Okay. Chapter number 2. In chapter number 2, we'll be moving on with the drainage pipe works. As we know this, pipe is a same. Pipe is referring to a tube or a pipe which is just to carry the water or transport the water or drain the water from one place to another. Okay, so now these terms, like you can see or you might have heard about, there are different terms given in the drainage side and the water side for the pipe works. Like I can say that is like here, if I say there are list of pipes, like I can say one is soil pipe, one is vent pipe, one is waste pipe, and one is like the rainwater pipe, and one is anti-siphonage pipe. Now this terminology or these terms is being given because of the work they are doing. So if you see here soil pipe, so what do you mean by soil pipe? Soil pipe is nothing but it is a pipe or a tube which is carrying the drain from the WC, urinals and bidet. In simple words, a pipe which is carrying, collecting and transporting the excreta is nothing but called as a soil pipe. For example, if you see here, it is written as a soil pipe, and this is a horizontal pipe connected to this vertical pipe. And here, if you see here, it's clearly showing that here WC will be fitted, and to that WC, this is connecting over here from the WC. Okay. That means the trap of the WC, this would be connected. Okay. So that means if it is like WC, urinal or a bidet, whatever the drain is being carrying along in such kind of pipe, that pipe is called as a soil pipe. Remember this. Now pipe 2, that is wastewater pipe. Now what do you mean by wastewater pipe? Wastewater is nothing but it's a clear water also, I can say. Wastewater is also known as wastewater, clear water. Okay, that means it is which is not having or which is not containing human excreta or the human waste, is nothing but the wastewater. So we know that if WC and bidet and urinals is not connected to this kind of pipe, then that becomes a waste pipe, or in simple words, the drain from entire building fixtures except WC, urinal, bidet, which is been collecting, that is called as a wastewater pipe. For example, see here that this is a laboratory over here. From here we have this faucet, and right and left you can see. So this is like the water, blue color, and the water is being moving in this direction from a trap. It is traveling to this horizontal pipe, and again this is also connecting to one vertical pipe so that the water goes out by means of gravity to the downwards. Same case in terms of soil. Okay, so now if you see here, this is clear water, as I said. So in simple words, wastewater is water which is not having human excreta. Now, where from human excreta comes? We know that if this is having like, if the pipe is being holding a human waste which is being generated from the WC, urinal and bidet, if we are not connecting, if we are not adding that, then that is, except that is like a complete wastewater. So if you see here, the fixtures except that 3, whatever the water which is being drained from that fixtures is called as a wastewater. So the pipe which is carrying such kind of water is called as a wastewater pipe, if you can see here. Okay, same thing, pipe carrying drain from all the fixtures except WC, urinal and bidet is called as a sewage. Next, third one is a vent pipe. Vent pipe is nothing but a pipe above a waste pipe or a soil pipe that allows the gases to escape from the system. For example, this I can say as a vent pipe, okay, or else consider this as a vent pipe. What happens whenever the flush happens? This is carrying along the waste, and this waste or the human waste is being collecting into this vertical pipe. This goes down by means of the gravity, and the gases will rise above, okay, and it'll try to what? Get disposed in terms of the atmosphere. And this ventilation pipe or this vent pipe is generally outside the building. Generally this is open to atmosphere, just to exhaust the gases into the atmosphere. Okay, so the extension of any soil pipe or waste pipe, I'm talking about the vertical pipe, that is nothing but a vent pipe. So we have a vent pipe in terms of soil, in terms of waste, both. So the same thing is been mentioned over here, a pipe above a waste pipe or a soil pipe. Waste pipe here refers to the vertical pipe. Here it refers to the vertical pipe for the soil, that allows the gases to escape from the system. And as I said, you can see this is outside of the project. I mean, this is at the roof level or the roof area. And you can see this is going above, and this is what exhausting the gases. Okay, I mean the sewer gases, which is natural gas. It is exhausting into the atmosphere. Pipe number 4 is a rainwater pipe. Now, rainwater pipe is nothing but the pipe which is being installed just to carry the rainwater from the roof area. Now, roof area, we do have 2 different kinds of roof. One is flat roof and second is a sloped roof. If you see, what kind of roof is this, anyone? Is it a flat roof or a sloped roof?
Slope roof, sir.
Slope roof. Very good. So if you can see here, whatever. See, either it is a flat area or either it is a sloped area. Whenever the rain occurs, it intercepts in this and it tries to goes down because by means of a slope, okay, by means of gravity. Likewise, if it is like incidenting on a flat surface area, then that water should also be removed. Okay, that how the process would be done we'll be studying in the later on classes, but right now rainwater pipe is a pipe which is just to collect and transfer the water to the ground level. Either it is a sloped roof or either is a flat roof, doesn't matter. Regardless of that, the main purpose to install a rainwater pipe is just to collect the rainwater from the roof areas and bring down to the ground level or to a drain point if we have provided that. Okay. The same thing has been mentioned, a pipe carrying rainwater from a roof or a roof gutter to the ground level or to a drain point, also known as a rainwater pipe. Usually in US and Canada, it is named as downspout. So this is a rainwater pipe, what you are seeing with a funnel over here. And if you are getting confused, let me explain you something about this. This is not a flat roof. This is actually a sloped roof. For sloped roof, we have gutters. This is semicircular thing. What you are seeing, it's called as a gutter. So when the water incidents on that sloped area, it comes by means of gravity and it gets into it. And this is having some kind of, you can see, if you keenly observe, this is having some kind of inclination towards this funnel so that the water gets entered. When it has been collected, it has been transferring into this funnel and it has been coming here. And this is the rainwater pipe, which is commonly known. And if you are dealing in like US and Canada and Western countries, they don't say as a rainwater pipe, they say as a downspout. Okay, it's one and the same. So the intention or the purpose to install is just to collect the rainwater from the roof areas and bring it down by means of a gravity to a drain point. Okay, so this is the intention to install a rainwater pipe. So as I said, don't get confused. The pipe remains same. It's a hollow thing. It's a tube or a pipe. As per the work or as per the job, what it is doing, it is termed as the work, what they are doing. Okay, so this is rainwater pipe or a downspout. Now next is anti-siphonage pipe. Now anti-siphonage pipe is also a pipe, but to understand an anti-siphonage pipe, you need to understand some terminology or some kind of like science behind this. What is anti-siphonage pipe? If you keenly observe this here, there are two WCs on different floors. This is, for example, a first floor and this is second floor, and this is wall. And behind that, if you see, there is one sky blue color pipe, and behind that there is one more pipe which is nothing but a soil pipe. Now just now we have learned the flush when it happens from the WC urinal or a bidet is which it collects is called as a soil pipe. Right or wrong, everyone? Come on. Yes, please. Yes, everyone. The pipe which is carrying the WC drain or a drain from the WC urinal and bidet is a soil pipe. So if you see here, when the flush is happening, the waste excreta is being carrying here and this is being collecting into this vertical pipe, and from here this comes down by means of gravity. Likewise from this ground floor, I mean the first floor also, if someone uses this WC, the same kind of thing happens and there is a bend over here and this is going towards the sewer. Either it is a public sewer or a private, whatever it might be. Okay, but this terminology, if you see here, this is anti-siphonage pipe. And if you see here, they are clearly mentioning that this part, or this pipe which is connecting to the sky blue color pipe, which is also known as a vent pipe here. Okay, so to this vent pipe, there is one small pipe connected. This is called as an anti-siphonage pipe. Now, what is the need of this? Generally, this kind of system we don't see in small projects. Okay, when we have a high-rise buildings, what happens is in actual practice, for example, if you are having 10 or 20 floors of the building, for example, let's assume 20 floors of the building, and someone used WC on the 18th floor, for example, and they have flushed. The moment they flushed, a huge amount of water comes drained out from this WC, and it has been coming here below by means of gravity. And we know that as it comes down, it picks up more and more gravity pressure. So what happens over here when it is coming down, it is having more pressure. Okay, and we know that this WC or any of the fixture, we know that they needs to have a trap. So generally WC, like what you are seeing is a Western WC. So it is having an integral trap. That means a built-in trap with it from the manufacturer it comes. Okay, if it is an Indian WC, then we need to install one P trap. So this is the S trap over here. So that is means we have a water seal over there. That means the atmospheric pressure in this toilet area and the atmospheric pressure in this is less. Here, because of this high pressure or the low pressure, I can say, the seal is been pulled out from the below fixtures. I mean, from 18th, when it is coming down, there has been chances that the seal which has been created over here, it might be sucked out into this pipe because of the change in the atmospheric pressure, because here atmospheric pressure is different and here atmospheric pressure is different. Here we are having is negative or low, you can say, or I can say here vacuum is been created. So it might pulled out this, or it might suck the seal from these WCs from the below floors. And not only this, it might, what happens over here? So this is not acceptable, because when the water is going like this down, when you have this bend or the turning, the moment the water is taking a turn, because of change in direction, the gases starts coming above because of the density, because gases are less dense. Okay, so it comes above and there is no water seal in this WC. Bad smell will be coming like this. Okay. And it might be coming out from the WC, or it might be coming out from the fixtures if we don't have a anti-siphonage pipe provided, and that is leading to discomfort, or it might be not having a healthy conditions or healthy atmospheric conditions or healthy conditions, I can say, within a building, which is not at all accepted. Okay, you might feel a bad smell or the odor we can sense in the project, which is not accepted. Okay, so what to do? You need to save this water seal. So what it does is, if you see here, this anti-siphonage pipe is being connected to one more vertical pipe. If you see, this is only the small thing is anti-siphonage pipe, this much, and this is complete vertical pipe is nothing but a vent pipe. So this anti-siphonage pipe is being connected to this vent pipes, and this vent pipe is open to atmosphere, that is above the roof, or it is above the last floor of the project. It is going towards the roof, and which is open. So what happens when the water comes down with some velocity? When it starts negative pressure, so what it happens, it draws some amount of water like this. Okay, and it serves water, and it allows the air, fresh air from the atmosphere, and that air will be moving on like this into this. So what is happening? The seal of this WC is being safe. That means if at all the seal is not broken, that means if at all the gases will try to come above, it will not enter into it. If at all it is entered, it cannot come because we have a water seal over here. So the gases has no option. It will go above and it might exhaust from this vent pipe. Let me show you once again, or let me read out, then I'll show you one animation. This pipe is provided in the house drainage system to maintain the water seal of the trap. Every fixture has a trap. Remember this, okay? Or every fixture should be given with a trap. What is trap and all this? In the later on classes, we'll be seeing this. When one of the upper floor toilets is flushed, a large amount of water gushes down the toilet line due to gravity. The rapid moving water creates a low air pressure directly above it. As I said, it directly creates lower pressure above that floors. Okay. Now, the toilet water seal has a normal air pressure on the toilet side. That means inside the toilet, we have a normal atmospheric pressure and the seal is normal over there. And the lower air pressure on the toilet side, because when it is going below, it is having lower the air pressure or the negative pressure or the suction. Okay, so this is what. Hence, the water seal in the toilet seat is sucked out in the pipe. In the sense, it is sucked out in the vertical pipe, okay, of the soil pipe, due to the difference in the air pressure that is being done because of the atmospheric pressure difference inside the toilet area and the soil pipe area. Okay, because this is having low pressure, so it is being sucked out that seal, and there is no seal in that trap over there, the water seal. Okay. As a result, the water seal is broken and foul gases can enter the toilet room. To keep the water seal, equal air pressure must be maintained on both the toilet room and the toilet pipe side. That means if you need to keep a water seal, you need to maintain the normal or equal atmospheric pressure on both the sides, like in the toilet area side and as well as on the soil pipe side. I mean the vertical pipe side. Okay. Therefore, to maintain that, an additional pipe, which is known as anti-siphonage pipe, is connected near the toilet seat outlet with the other end open to the atmosphere. The anti-siphonage pipe allows atmospheric air to enter the low pressure zone and equalizes the air pressure. Thus, this type of drainage pipe prevents the water seal from being sucked out of the flushed toilet seats, as well as all the toilet seats connected to the floors. Connected to the lower floor. This is most suitable for the multi-storied buildings. Now let's see. I'll try to show you one animation. Try to observe this. People will be getting an idea. First of all, if you see here, what does an anti-siphonage pipe do? Okay, if you see here, then second thing, when the foul water is discharged from the upper floors, it causes suction in the drainage pipes. See here, they'll show you one example. Everyone, see here, this direction, which is nothing but this is a soil pipe, everyone, and this is a horizontal branch which is bringing the soil, I mean the excreta or the human waste from the WC. Okay, if you can see here, there is a WC. From here it comes here like this, and someone is flushing by means of this horizontal pipe with respect to this T, that this water is getting entered into this vertical pipe and it is going down. Okay, so what is happening when the foul water is discharged from the above floors? That means the foul water it is coming down from the topmost floors or the above floors of this floor. Okay, so let's see this. Suction in the drain pipes might happen. So if there is no anti-siphonage pipe, so this is an anti-siphonage pipe. Just now we have learned that this is a vent pipe which is connected to this anti-siphonage pipe. An anti-siphonage pipe is a pipe which is connected at the outlet of the WC. So this is what it is saying. If it is not there, then what happens in the case one? If you see, if it is not there, pay attention. Just now they have flushed the water. See, a certain amount of water is being flowing towards this vertical pipe. It entered. And what is happening? See, there is been, this is red color is the odor and the bacteria entering into the project. And if you see, this is coming out of the WC also, which is not at all accepted. The odor or the bad smell or the impurities of the bacteria. Okay, it is causing discomfort and it is not a healthy atmospheric conditions within a project. So to maintain or to save the seal, we have an anti-siphonage system. So anti-siphonage pipe, if you see, if we have this, whenever this is having example, when this water is going down, when it tries to suck this seal of this WC, it can't. Why? Because when it's tried to do this anti-siphonage pipe, which is connected to this horizontal pipe, and this horizontal pipe is connected to this anti-siphonage pipe, and this anti-siphonage pipe is connected to this vertical pipe, which is nothing but a vent pipe over here, and this is open to atmosphere at the other side. So whenever there is a suction or negative pressure, so when it tries to suck, what happens? It is not sucking the water. It is not breaking the seal of this. It is bringing the fresh air, or it is dragging the amount of air from the atmosphere, and it is going like this. In that manner, this water seal is being saved. Got the concept of anti-siphonage? Now, let's move on.
To maintain the water seal.
Yes, to maintain the water seal.
Water seal trap.
Yes, to water seal trap. As you said, to maintain the water seal of the traps, because every trap has a water seal, right? To save that.
Yes.
Because if there is no water seal, then you know that what are the discomforts would be happen, and that is not accepted. Okay. Now let's move ahead towards the chapter number 3. Now chapter number 3 is nothing but the type of the drainage system. So there are commonly 3 drainage systems. One is single stack system, second is one pipe system, third is 2 pipe system. What do you mean by single stack system, and what do you mean by one pipe system or a 2 pipe system, or also known as double stack system? So what do you mean by this? Let's quickly move on with this. But before moving on with heading towards the single stack or one pipe or 2 pipe system, first of all, let's understand what exactly the stack is. Okay, a stack is nothing but it's a main vertical pipe that carries away the discharge from all the plumbing fixtures. A stack, in simple words, if I say you, is nothing but a vertical pipe which is carrying the waste or a soil in a pipe, which is coming by means of a gravity, because it's a vertical pipe. So stack is nothing but it's a main vertical pipe. Why I'm saying main? Because even if it is, for example, the entire project, whatever the drain is happening will be collected into this pipe, and it will be coming down by means of gravity. So that is why it is called as main vertical pipe. Okay, that carries all the discharge for all the complete plumbing fixtures. Okay. Next, if you say this, carrying drain from WCs, urinals is called as a soil stack. Now, but before this, what is a stack? I'll show you. I can say these as a stack. Okay. This one as a stack. This is not exactly a soil pipe. This is a soil pipe, I can say. This is a soil stack. Why? Because if you see here, from here, the human waste or the excreta dumped into this vertical pipe. From here also the same thing happened into the same pipe. So this is a soil stack. Okay. Once again, stack is nothing but a main vertical pipe which is carrying all the building drain, the drain from all the fixtures. All the fixtures refers to what kind of fixtures. If it is carrying the drain from the fixtures, like I can say as excreta, which includes of like WC, urinal and bidet, that is called as a soil stack. That means that main vertical pipe, in that you have is human waste and excreta, and that is being generated from WC, urinal and a bidet. Second thing, if you are having a same vertical pipe which is connected to the if it is connected to the laboratory, or if it is being connected to the wash basins, or I can say as a washing machines or floor drains or a baths and all this, so that is called as a wastewater. So if that wastewater is connected to a vertical pipe, that pipe is called as waste stack, okay, or wastewater stack. Remember this stack. Remember, stack is nothing but a vertical pipe. If it is carrying the drain from the WC, urinal and bidet, that becomes a soil stack. If it is carrying apart from these three fixtures, then that becomes as a wastewater stack. Okay, so these are the two stacks and these are the two differences. So let's see this. A stack is nothing but the main vertical pipe that carries away discharge from all the plumbing fixtures. Carrying drain from WC urinals is called as a soil stack, or you can add bidet also, because remember, bidet drain should also be connected to soil stack. Everyone remember this, or the bidet drain should also be connected to the soil pipe, and then it needs to connect it to the soil stack. Carrying drain from other clear wastewater fixtures is called as a wastewater stack. Okay, apart from these three fixtures, the water which is being drained out and collected into a vertical pipe, that vertical pipe is called as a wastewater stack. Okay, now what do you mean by a single stack? Just now we have learned about what exactly the stack is. A stack is something that is a main vertical pipe. So now single stack. Single stack means that is only one vertical pipe in the system. In simple words, if I say you, this is the most economical of all the stack systems, like either if it's two pipe or one pipe, or this is in terms of like single stack and all this. So this should be done in this manner. Okay. Single stack is something where the excreta and the sewage both is being collected in only one vertical pipe. That is why it is called as a single stack. That means the drain from the WC, urinal, bidet. Not only this, other than that also, like the wastewater generating from the fixtures like laboratory and bathtubs, etc. That is also being carried along in the same vertical pipe. So that is mean there is one common pipe, okay, I can say as a vertical pipe or a stack. It is a common, okay, to dump the sewage as well as the excreta. So that is why it is called as a single stack system. Now it is having some terminologies and some kind of like you need to have some idea, or you need to have some knowledge to design this system. And this system, what I am dealing right now, the systems and all this is being taken from NBC, okay, National Building Code of India. So if you see here, single stack, if you want, I'll give you the reference also. You can go from NBC, volume number 2. This stacks has been given over there. Okay. And if you want more detail, if you want to study, you can study from here. See, for a single stack system, 2 pipe system, 1 pipe system, see 1 pipe and 2 pipe is also given. Apart from this, see 2 pipe system. So this is all is given. So the source, what I'm saying you, I have taken this from a NBC, that is National Building Code of India, volume 2. So now let's coming back to the single stack system. Now single stack system is nothing but which is a system which is conveying both soil and wastewater combined to a single drain pipe as well as providing ventilation. That means this one vertical pipe is not only collecting the sewage and the excreta, at the same time, it is acting as a vent pipe also. So this is a single stack. Okay. So the piping system in which there is no trap ventilation and the stack itself acts as a vent through roof. Now, what do you mean by trap ventilation? Like it is directing you towards the ventilation respective or individually to the fixtures. It has not been done. So here the ventilation which is taking place is in terms of the stack ventilation. That means we are not we are not having any logical pipes which is been connecting to the fixtures and the ventilation is being done. No, it's not like that. Here, when the water is being drained out from any of the fixture, it has been collected into one vertical pipe, and when the water goes down above, the gases, because of the they are less in dense when compared to the water, that goes down by means of gravity, gases tries to evaporate. So both the things, that means it is acting as a ventilation pipe also. So that is what. So this is the most economical stack system among these three systems, that is single stack, one pipe and two pipe system. If you pay attention to this, this is given as per NBC. Just now I've shown you single stack system. If you pay attention, ground floor, first floor and second floor. Here, this is a common soil and waste stack. As I said just now, vertical pipe is a stack. So here is a common. This is a common pipe. Why I'm saying common? Because when the WC from this area is being flushed out, you can see this is being connected by means of a T in this vertical pipe, nothing but a stack. And from here, this wash basin, the water is coming down by means of this bottle trap. It's coming down, again turning. Then it is being connected to this floor drain. From this floor drain, it is coming again here, and this has been connecting into this horizontal branch. Okay, here. And this horizontal line is been again connecting to this one line. That is nothing but again a common stack. That is why it is set as a common stack, because this stack is not only carrying the waste from the WCs, from these fixtures also. That means, in simple words, in single stack system, excreta and sewage both is being carried only in one single pipe. Okay. So if you see here, this is a wash basin. So this goes down, and from here is a floor drain, and here is a shower. So this floor drain, when in terms of a shower is working, the drain from the shower will be carried along from this floor drain, and again it is being collecting into this. This is being sending into this horizontal pipe, and wash basin, it's coming below, and there might be some water like here, it might come out of the basin while serving. So this is being collected from this floor drain area, and again it is being serving. So in simple words, if you see this is a single stack system, but single stack system, there are some like the enclosures to be followed, which is given from NBC. So if you are dealing with the single stack system, there are some parameters to be followed. Very first parameter, NBC says that you need to make sure that on every floor, it should not have more than 2 toilets connected. Okay, if there are 3 toilets, then you can't opt this system. First one. Okay, second thing is like they says that it is only suitable for like 5 floors of the building, not more than that. If the floors of the building is exceeding more than 5, then this system is not recommended from the code, okay, or the standards. Now, apart from this, there are some simple things given over here. They says that the WC distance of the WC of the horizontal pipe should not be more than anyone 2400 mm. That means the vertical pipe from here, WC, from here to the stack, the distance should not exceed more than 2400. That means it should not have exceed more than 2.4 meters of the distance. Okay. You need to keep in mind the WC should not place more than 2400 mm or 2.4 meters. Except that all the fixtures except WC can be placed of a maximum of 3.5 meters or 3500 mm. If you can see here, that is what it has been shown over here, that the flow drain for the shower and the flow drain for the this wash basin and all this, it is okay. That can be till 3500. Remember this. Okay, one more point. And always remember that this WC connection should always be above, below this wastewater pipe. Always the soil connection should be above and this wastewater pipe should be below. Likewise on the same floor, likewise on the next floor also. So it should be done like this. Okay. And as I said, that this is not only carrying the drain of this both the sewage and the excreta, it is also acting as a ventilation pipe. If you can see here, till here here it is like carrying the water, and here it is the drain, and this is the topmost floor, because after this there is no floors. Here they are saying this is a terrace floor level. Okay. So from here, if you see, now this stack from here, this much is acting as a ventilation pipe. That means it is like exhausting the gases into the atmosphere. True, everyone? Yes or no? Okay. And one more thing, they says that the distance between this, this soil and the wastewater line should not be in between, or it should be minimum of 200 mm. That means the distance from this mid and this mid should be a 200 mm of the distance between the bath waste and WC. You can see here, this is the bath waste and this is the WC waste. Okay. And apart from this, they says that the topmost floor above the ground floor, that is first floor, that drain from this area, if you can see the area from here till this invert level of the drain, this is a building drain, you can say. Okay. So when it is turning over here, we are having a radius. So this is a building drain, I can say. So this building drain invert level, and invert level is nothing but the water which is lying at this level is nothing but the invert level of this pipe. So from this bottommost thing to the topmost thing of the previous floor, the height, if it is like, you can see here, it is clearly saying that it should not be, if it is like 2500 minimum, it should be there. If it is not, then you cannot connect this. In simple, what I'm trying to say here is, from this topmost fixture, okay, the distance from here to this invert level of the pipe of the building drain should be minimum of 2500 mm or 2.5 meters. If it is there, then it's okay. Or else if it is not there, then you can't connect. It has been recommended that you should not connect the fixtures on the ground floor to this stack. Why? Because if you connect this drain of this WC here and these things, if you try to connect into this, then this will have some interruption of when the water is allowing it fall free, then it'll interrupt this. So it is not accepted at all, because it should be falling free. Okay. So if the distance from here till here is 2500, if it is there, then this WC is below that, then you can connect. Okay, remember this. But generally we don't get that much. Okay. So it is recommended that the distance should be 2500 mm or 2.5 meters. If it is there, then you can connect this WC or these fixtures into the stack, or else you should not connect. Then this fixtures should be connected directly to the manhole. You can see here to the GT and to the manhole, that is the gully trap or the manhole. Now, single stack system, This is the most economical stack system which eliminates a separate ventilation stack. That means this is the most economical, cheaper you can say, which is eliminating one more pipe that is used for mostly for the ventilation to exhaust the gases, because there is no separate pipe for the gas, or the vent pipe is not installed. So it is eliminating. So it is more cheaper. That is why. Okay. The single stack system is ideal when the toilet or the fixtures layouts are repetitive and there is less space for the pipes on the wall. Now, this has been recommended or suitable when the fixtures are repetitive on every floor, the same location and all this. And if the project is small, we don't have much space in the walls and all this, then this is most suitable and it is very economical also. You can go with this. In any system so selected, there should be not more than 2 toilet connections per floor. As I said, you need to check if there are only 2 toilets on each floor, then you can opt this. If it is exceeding more than 2, then you can't proceed. This points what we are discussing, it has been set as per NBC, National Building Code of India. Okay. This system requires a minimum of 100 mm of the diameter stack. The minimum diameter stack should be of 4 inches, not less than that. Now we'll be calculating at the time of calculation. It might increase also, but it should not go minimum. This should be for sure. This is the least. Okay. This is most suitable for a maximum number of 5 floors in a building. That means this is suitable for a building which is 5 floors, not more than that. In this system, care shall be taken to the horizontal distance of a sanitary fixture from the drainage stack and the vertical distance between connections of a branch from the fixtures to the drainage stack. What? It has been said here. WCs shall be connected to the vertical pipe, that is nothing but a stack, through a sanitary tee. The maximum horizontal distance from the stack should be 2400 mm, as I just not showed, or 2.4 meters, like this. It should not exceed more than this. This is what saying, and this is apart from WC. This can be 3500 mm or 3.5 meters. The same thing, or 2.4 meters other than WC. Maximum horizontal distance which shall be connected to the stack shall not be more than 3.5 meters or 3500 mm. The vertical distance between the branch waste and the soil connection, when soil pipe is connected to the stack above the waste pipe, it shall not be less than 200 mm. Like I said, this should not be more than 200 mm. And always this soil should be above, this waste should be below. And you can see this should be minimum of 200 mm, not less than that. That should be the distance between these both. Or else if you are connecting it the same, then it might get mixed up and there has been chances of a blockage or a cloggage. Okay, that is what. Vertical distance between the lowest connection and the inward drain shall be 2500 minimum. That means the topmost after the ground floor, if you are having 2500 of the meters of the distance, then you can connect the groundwater fixture to the soil stack or the stack or the vertical pipe, or else you can't. Okay, so that should be minimum to allow the free flow from the top floors. If you are getting 2500 mm, that's very good. Then you can connect the ground fixtures, or else no. Okay, but generally we don't get, so generally we don't connect. For the tall buildings, ground floor fixtures are recommended to connect directly to the manhole or the inspection chamber to have a smooth flow in the stack. The size of the vent pipe shall be same as the size of the drainage stack in the case of a single stack system. So the vent pipe and the drain or the stack size should be same. Even that stack is acting as a ventilation pipe, the same pipe should be extended as a vent pipe of the same dia. That is what it is meaning. As the stack act as a ventilating pipe, the top of the outlet shall be covered with a durable wire mesh or a cage which does not restrict the sufficient flow of air. That means here, if you see, this is a wire mesh which is it is like on the vent side, okay, or the vent pipe. You can see it should be covered with a wire mesh, but it should not be in such a case that it is restricting the air. In simple words, restricting the air in the sense that it should be having exchanging of air. That means exhausting the gases outside, and when needed, it can bring down the fresh air also. Okay, so it should not restrict the sufficient airflow. A minimum height of 50 centi or 0.5 meters above the roof shall be given for the stack to the top outlet to avoid bad smell. For example, if someone goes on the roof area and all this, this should have minimum of half meter of the height from the parapet level, so that if someone is here, they should not feel the discomfort. And one more thing they say is that this vertical riser, or this stack should have a minimum of 3 meters of the distance from a living area, like example doors, windows, or any kind of thing, so that they should also not feel the discomfort below floor people. Okay. Same thing is mentioned on the next point. Stack outlet shall also be a minimum of 3 horizontal distance meter away from any type of the house ventilation, such as doors, windows, etc. The bend of the foot of the stack shall be of 200 minimum radius or more. That means this bend should be of minimum of 200 mm or more. Okay, so these are some important points you need to keep in mind. Then only you can opt, or then only you can make your mind that what kind of system we can choose up with. Okay, so I'll just stop here, everyone. Thank you so much for your valuable time.